Okay, so let's take a look at the problem. We're dealing with f of x, so let's just write that out for part A. F of x is some sort of polynomial with a real coefficient, and it's got some zeros that it gives us. So let's start with our leading coefficient. Let me just pull up full video here. Okay, hopefully that's good. Let's zoom in. Okay, so it gives us a leading coefficient a sub n, which equals -3. And since it's our leading coefficient, we could go ahead and write it in at the front of f of x here before we write in our zeros. So for the zeros, it gives us 1 plus I, and we also have 4. So let's start with the easier one, 4. So we can write in this term because when x equals 4, this term is going to become 0, and f of x will then equal 0. Now let's look at the other 0, which is 1 plus I. We can just do the same thing here. So we take the inverse of it and we add it to x. So when x equals 1 plus I, this term now becomes 0, and f of x becomes 0 also. So that's another 0. But let's take a look at this now. If we were to multiply this out, you'd end up with the highest degree term would be an x squared because you have an x times an x. But this problem says that we have a degree 3 polynomial, which means that this needs to be multiplied by x again, or we should have some other 0, some other term here that's x plus something else. And the reason for that is we have this certain property called complex conjugate zeros, which says that if you have a complex conjugate like 1 plus I, or I'll say more generically, a plus bi, in this case a is 1 and b is 1, so you just have 1 plus I, then it's true that there's another 0 in the polynomial that exists that's a minus bi. So since we have 1 plus I, then there must also be a 0 that's 1 minus I. So we're going to take that 0, take the inverse of it, put it right in here, add it to x. That's going to give us our last 0. I'll leave that up for you to do. And then in part B, you'll see that f of x is a degree 3 polynomial when you expand it out. Expand just means that you're going to multiply this term out. And as you do that, just remember that I times I is -1. Okay? So I hope that helps. If you need any other assistance, just leave a comment below and I'll help clarify it.